Hi, everyone. What I want to do is go over collected homework one that was due, on Friday. The scores were a little low. I usually like to have a median of a B, about an 80. This was more around a C-ish, maybe 75%. And so to be perfectly frank, if you did not do well in this homework, understand that the course will get quite a bit more difficult, quite a bit, quite quickly. So just be aware of that. This is a 300 level math course. Yes, it's cross-listed as Economics 351, but this is a course that's a math course. I'm a math professor. I'm not an economics professor, so just be aware. It's no shame if just this course is not for you. All right. Well, without further ado, let me get into the homework. So yeah, Alicia invests 5,000 into account, and I'm giving you the interest rates for the next 2 years, basically. Find how much Alicia has in the account after 2 years, and find the equivalent effective monthly interest rate for the 2-year period and the equivalent effective annual interest rate for the 2-year periods. Okay, so a lot in this problem, but there's not, it's pretty straightforward. So we start off with $5,000, and so you can explicitly say after each interest rate change how much you have in the account. I think it's much easier to do it like I did in the video and just do it all in one shot. So after 2 years, T is in years here. Well, 5,000 grew to 5,000 times 1.003 to the 6 after 6 months. So $5,000 earns 6 months of interest at a monthly interest rate of 0.03%. So 0.3%. So divide by 100, 0.003 is the actual interest rate. So the growth factor is 1.003. So 6 months of monthly growth at 0.3%, 1.003 to the 6th. Okay. That earns 1 year of interest at a monthly interest rate of 0.5%. So that means it's going to be 12. It earns 12 months of this, earns 12 months of interest at this monthly interest rate. Okay. And that earns 6 months of interest at this monthly interest rate of 0.8%. So it's going to be this to the 6th. And that is, you dump it into the calculator, 5,669,32738. Okay, so the equivalent effective monthly interest rate is there then set up in the following way. So remember, we're trying to find an interest rate, I'll call it J, a monthly interest rate, where if I put $5,000 into an account, earning this monthly interest rate and let it sit for 24 months, 2 years, I'll have exactly how much I have in the account, which is $5,669 and roughly 33 cents. So solve for J. And certainly if you forget how to solve for J, then this probably is not the course for you. So the third homework is going to be very math heavy and very calculus heavy. So just making that clear. You really have to know how to, at the very least, solve for J in an example like this. So you get 0.00525, which is 0.525%. Okay. And for the equivalent effective annual interest rate, and before I forget, I'll do this for all the homeworks and the exams. I'll make a video on how to basically do them. All right, so 5,000 again sits in an account earning this yearly interest rate, I'll call it I, for 2 years. So it earns 2 years of interest at this interest rate that we're trying to figure out. And we get exactly how much, well, we have, which is 5,669 and 32738. So we solve for I 0.06483, 6.483%. Okay, so number 2. Yeah, I'm not going to do it the long way. I'm honestly not sure if I'll even accept it on the exam. First of all, most people do it wrong if you do it the long way, because it's an absolute pain in the ass, especially for this problem. If I had more than 2 deposits, it would be even harder. And it's just not a good way to do it. It's very antithetical to basically this entire course doing it the long way. I actually meant to say for this homework that I don't want you to do it the long way. I forgot to do that. So if you did it the long way and get it, if you got it correct, I gave you credit, but it is not a good way to do it. Secondly, for a problem like this, draw a time diagram. It does not take long. Okay, so 4,000 is my initial deposit. I have another deposit of 5,000 at the end of the first year, which is t equals 1. And then at t equals 4, at the end of the third and fourth year, we have withdrawals of x. But we also have a 2% penalty on each withdrawal. So 2% of x is 0.02x. And sorry, there should be a minus. It's the withdrawal. All right, so we're given that we have 10,000 at the end of the 5th year. Okay, so now thanks to this time diagram, it's effortless to see how much time each deposit or withdrawal accrues interest for. 4,000 earns 1, 2, 3, 4, 5. I didn't write 5. I mean 2. I guess you could, but it doesn't matter. 1, 2, 3, 4, 5 years of interest. So 10,000 is how much we have at the end of the 5 years. We're given 6% is the effective annual interest rate. 5,000 earns 1, 2, 3, 4 years of interest. Put that up. So this is minus 1.02 x. And that earns 1, 2 years of interest. I guess you don't really need this bracket here. And this minus 1.02 earns 1 year of interest. So yeah, I'll trust that you can solve for x. 747 and roughly 68 cents. Okay, so for 3, So as I said in the video, if you literally take the average of these interest rates, I'll be, not happy and penalize you quite a bit, and I did. I'm not looking for literally the average. It's just sometimes called, as I explained in the video example, sometimes it's called the average growth rate. But really, and I specifically clarify this in this problem, I really want the equivalent effective annual interest rates. That's what I'm asking for in this problem. Okay. Okay, so yeah, I'm telling you what the fund does in time periods. So if you want to write down like a chart, you can. I don't really think it's necessary. Okay, so let's work with little a. So at the end of 5 years, remember little a of 5 is just what $1 does. So I'll just write 1 to emphasize we're working with $1. So just like I did in video and lecture, in the year 2010, $1 grows by 2%, so it's 1.02. That itself in 2011 grows by 5%, so it's times 1.05. That in 2012, that grows by 2%. So it's 1.02. So I actually fixed this. It was a 2 here, decreases 2%. So that means I'll write it out here. It's really 1 plus 0.02, 1 plus 0.05, 1 plus 0.02. So it's 2% growth, 5% growth, 2% growth, 2% decrease, so it's 1 minus 0.02, which is 0.98. And last but not least, in 2014, it grows by 1%, 1.01. So this is 1.08128. So to emphasize, this is 2010 through 2014. Okay. All right, so if I want the effective annual interest rate for the 5-year period, again, we ask the question, if I take $1 and I dump it into an account earning, let's call it I, earning this interest rate, and I let it sit for 5 years, I'm going to have exactly how much $1 actually grew to in 5 years, which is $1 and roughly 8 cents. Okay, so let's find that hypothetical interest rate. And that's going to be 0.01575. And remember, this is super practical stuff here. This is giving you like a benchmark for, the average growth over the 5-year period. The growth in this fund, even though it goes up and down, it behaves like a bank account earning 1.6% interest. Okay? And that's very valuable. 1.6% interest over the whole 5-year period. Okay? That's a very valuable benchmark to kind of answer the question of, is this a good investment or maybe it's not a good investment? Yeah. Okay, for 2010 through 2012, beginning of 2010 to the end of 2012. And again, this is beginning and beginning of 2010 to the end of 2014. Okay, so here, yeah, so $1 grew by 2%. in 2010, grew by 5% in 2011, and 2012 grew by 2%. So this is going to be 1.09242. Okay. So for the 3-year effective annual interest rate, again, we want this interest rate, I'll call it again, where if we dump $1 into this account earning this interest rate and we let it sit for 3 years, so it accrues 3 years of interest at this annual interest rate, we're going to have exactly what $1 grew to in 3 years, $1 and roughly 9 cents. So this is going to be 0.0299, so about 3% effective annual interest rate. Okay. All right, last but not least, most people got this right. They forgot to do simple interest at the end, which, and we're not going to do simple interest that much in the course, but I will throw it in every now and then, so you do have to remember it or understand it. So, yeah. All right, so doing this just like we did in the lecture example. So so 75,000 earns for full years 3% interest, effective annual interest. So we basically just solve for T, number of years that 75,000 sits in the account, and then we're going to round down. So 75,000 earns interest until we hit 125,000. So, right. So you solve for T. Again, you really need to be able to solve for T in this course. It's a 300 level math course. So you get roughly 17.28. Okay. So we're going to round down and see actually how much $75,000 grew to in 17 years. Dump this into a calculator. It's 123,963.572. Okay. And if this is confusing, you can actually just take a look and see that if we do one more year, so this time 75,000 times 1.03 to the 18, we're going to have 127,000, which is more than 125,000. So, so this is the correct answer. The 75,000 sits in the account for 17 full years and then starts to earn simple interest. So, right, 125. So let's figure out the fraction of years that money sits in the account after 17 years. So for fractions of years, the problem says it earns simple interest. So 123,963.5724 sits in the account and earns simple interest at 4% for S number of years. S is a fraction. So we solve for S and we get 0.20902 for a total of 17.20902 years. All right. Yeah, hopefully this helped. And yeah, do come to office hours if you have questions. And this course is going to get a lot harder. Just being honest, it'll get a lot harder, especially when we do annuities. You know, it's a 300 level math course, so it is on par with other 300 level math courses, ranging from differential equations to abstract algebra to, you know, maybe not as hard as basic analysis, but that's 302. I forget what basic analysis, but anyway. All right. So long. Take care. Hopefully this helps. And yeah. Bye-bye. Have a great day.